How do you measure the height of a tower you can't climb, or the width of a river you can't cross? You don't need a tape measure. You need one right triangle and the trig ratios you already know. This whole chapter is really a single skill. Turn a word problem into a right triangle, pick the right ratio, and solve. Let's learn the 3 words you need, then the one method that cracks every problem. Start with the picture. When you look at an object, the straight line from your eye to it is called the line of sight. Now build the triangle around it. The vertical height of the object is one leg, the horizontal distance along the ground is the other leg, and that line of sight is the hypotenuse. The right angle always sits at the foot, the base of the object. Every problem in this chapter is just this triangle. 2 angles matter. If the object is above your eye level, the top of a tower, say, you raise your head to see it, and the angle your line of sight makes with the horizontal is called the angle of elevation. Above eye level, look up. Elevation. If instead the object is below your eye level, a boat seen from a cliff, you lower your head, and the angle your line of sight makes with the horizontal is the angle of depression. Below eye level, look down, depression, and notice the word in both. The angle is always measured from the horizontal, never from the vertical. Here's the fact that unlocks half the problems. The angle of depression of a point, seen from the top of a tower, is exactly equal to the angle of elevation of that top, seen from the point. Why? They're alternate angles between 2 parallel horizontal lines. So whenever a problem gives you a depression angle up high, you can slide it down and use it as an elevation angle inside the ground level triangle. One thing students forget: if the observer has a height, their eye is 1.5 meters up, say, then the height your triangle gives you is only the part above eye level. To get the true height of the object, add the observer's height back at the end. Always add it back. So we have the triangle and the angles. Now the method, and it's the same every single time. Draw the right triangle. Mark what you know and what you want. Pick the ratio that links them. Solve. Let me show you which ratio to pick. 3 choices. If your known and unknown are the height and the ground distance, use tangent. That's the workhorse. You'll reach for it 90% of the time. If they're the height and the line of sight, use sine. If they're the ground distance and the line of sight, use cosine. And the angles are almost always the friendly ones, 30, 45, 60. So read tan, sin, and cos straight from the standard table. Let's solve 1. A tower stands 15 meters from a point on the ground, and the angle of elevation of its top from that point is 60 degrees. Find the height. Height and ground distance. So tangent. Tan 60 equals height over 15. Tan 60 is root 3, so the height is 15 root 3 meters. 1 ratio done. A shortcut worth memorizing. At 45 degrees, tangent is exactly 1, so tan 45 equals height over distance becomes height equals distance. Whenever you see a 45-degree angle, the height and the ground distance are simply equal. No calculation needed. Now one with an observer's height. A person 1.5 meters tall stands 28.5 meters from a chimney, and the angle of elevation of the top is 45 degrees. The part of the chimney above the eye, tan 45 equals that part over 28.5, and since tan 45 is 1, that part is 28.5 meters. Now add the observer's height. 28.5 plus 1.5 equals 30 meters. That's the full height. The harder problems have 2 triangles that share a side, a building with a flagstaff on top or 2 observation points, or an elevation and a depression from one tower. The trick is always the same. Write one equation for each triangle, both involving the shared side, then eliminate that common side between them. 2 equations, one unknown. Classic example. A tower's shadow is 40 meters longer when the sun's elevation is 30 degrees than when it's 60. Let the height be h. At 60, the shadow is h over root 3. At 30, it's h root 3. Their difference is 40, so h root 3 minus h over root 3 equals 40. Solve, and the height comes out to 20 root 3 meters. 2 triangles, 1 shared height eliminated. One habit that saves marks. Always substitute the exact standard value first. Tan 30 is 1 over root 3, tan 60 is root 3, and keep your answer in surd form. Only at the very end, if the question asks for a number, approximate, using root 3 is about 1.73. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Height and ground distance. So tangent. Tan 45 equals 10 over the distance. Tan 45 is 1, so 10 over the distance is 1, which means the distance is 10 meters. That's option A. Lock it in. Line of sight from the eye. Elevation when you look up, depression when you look down, both from the horizontal. Depression equals elevation by alternate angles. Then the recipe. Draw the triangle, choose tan, sin, or cos, solve, and add the observer's height if there is one. Last challenge, it's on the screen. Don't say it aloud, type your answer in the comments and I'll pin the right one. And that's applications of trigonometry. Every heights and distances problem is just a right triangle and a ratio. Free notes with 60 practice questions are in the description. Subscribe for the next chapter. This is Clarix. Keep going.